In this lecture, we are going to find the solution of system of non-homogeneous linear equation with constant coefficient. They will be of the form x dash equals to ax plus g of t, where g of t is a non-homogeneous term. And question number 1 about it will be to solve the following linear system, non-linear system of differential equation. So dx1 over dt equals to 4x1 plus 1 over 3x2 minus 3 into e power t, and dx2 over dt equals to 9x1 plus 6x2 minus 10 into e power t. So we are going to have that these terms are the non-homogeneous terms. G of t, we represent it by g of t, and A is the matrix which is the coefficients 4 and 1 over 3, 9 and 6. So this becomes a matrix A, and g of t is the non-homogeneous term here, and we are going to find the solution as we are going to suppose that x equals to v into e power lambda t. V is the eigenvector and lambda is the eigenvalue, and we say that we suppose that this is the solution of the given system of equation. In order to find the solution of this, we have to find a minus lambda I into v and put it equals to 0, and we have to find the corresponding eigenvalues and the corresponding eigenvectors of the matrix A. In order to find this, first we have to find the characteristic equation as we have to find the determinant of A minus lambda I, and determinant of A means A is the matrix, and it is the elements are 4, 1 over 3, 9 and 6 minus lambda into I is the identity matrix, that is 1, 0, 0 and 1. And here we are going to have lambda, we just multiply with that, and after that we just find the determinant of this matrix, and we just multiply this diagonal elements 4 minus lambda into 6 minus lambda minus 9 multiplied by 1 over 3. So when we simplify them, we will get the answer as lambda square minus 10 lambda plus 21. Now this is a characteristic equation. Now we have to find the values, the eigenvalue, and in order to find the eigenvalue, we are going to factorize this equation, and after making the factors, we will get that the lambda 1, which is the first eigenvalue, that is equals to 3, and lambda 2, that is the second eigenvalue, that is equals to 7. So lambda 1 is 3 and lambda 2 is equals to 7. Finding the eigenvalues corresponding to the eigenvalue lambda 1 equals to 3. So we have to find the eigenvector corresponding to this eigenvalue. Lambda 1 is equals to 3. So in order to find that, we put lambda 1 that is equals to 3 and A minus lambda I into the vector V. So when we just subtract them, so we get 4 minus 3, it will be 4 minus 3 is 1, and 1 over 3 minus 0 will be 1 over 3, 9 minus 0 is 9, 6 minus 3 will be 3, and multiply them with vector v1 and v2, and we will get the required equation as v1 equals to 1 over 3, v2 equals to 0, and 9v1 plus 3v2 equals to 0. When we put them equals to 0 and we solve them, so we will get that v1 equals to minus 1 over 3 v2. And we suppose that if v1 is t, here just put v1 equals to t, so v2 will be equals to, we multiply 3 with here with minus 3, so we will get v2 equals to minus 3t. And how to write the eigenvector? That vector v1, it is equals to v1 and v2. v1 is t and v2 is equals to minus 3t. T we take common, and then the eigenvector will be 1 and minus 3. So the solution, the corresponding solution will be of the form x1t equals to v1 into e power lambda 1t. v1 is this matrix, so we will write down 1 and 3. v1 is the eigenvector, and the eigenvalue that is equals to also 3 here. So here is lambda 1 is the first eigenvalue, that is 3 multiplied by t. So this is the first part. The second part is how to find the eigenvector corresponding to the second eigenvalue, that is lambda 2, that is equal to 7. And substitute the values here. Here is the lambda value, that is 7. So subtract this. So we get in the end minus 3, 1 over 3, 9, and minus 1. Multiply with this vector v1 and v2. So we will have the system of equation as minus 3v1 plus 1 over 3v2 equals to 0, and 9v1 minus v2 equals to 0. So we take any one of them or any one equation. So we get 9v1 minus v2 equals to 0. So 9v1 will be equals to v2. So we suppose that v1 is t. So if v1 is t, then v2 will be equals to 9t. And the corresponding eigenvector v will be equals to v2, that is equals to t and 9t. Take t as a common. So we will get the eigenvector as 1 and 9. So the solution we are going to write as follows, that x2 t equals to v2 into e power lambda 2t, where v2 is the same eigenvector which we have just found, that is 1 and 9. And e power lambda 2, here must be lambda 2. Lambda 2 is 7. So we will write here 7t. The homogeneous solution for the given system of equation, the system of equations is that we will write down the solution for the homogeneous part of this, and it is equals to v into e power lambda t, where v into e power lambda t, and here is x1 and x2 multiplied with c1 and c2, and x1 is nothing but we have just seen over here, x2 is v2 into e power lambda 2t. v2 into e power lambda 2t, and x1 is v1 e power lambda 1t. So lambda 1 is 3, and v1 is 1 and minus 3, v2 is 1 and 9, and lambda 2 is 7. So now, in order to solve for the non-homogeneous part, we must find the diagonalization. For this, we have two eigenvalues. Now we have to consider the eigenvalues as well as the eigenvectors. So the eigenvalue, first eigenvalue is 3, and the second eigenvalue is 7. And the corresponding eigenvectors are 1, minus 3, 1, and 9. So we have to make use of these two eigenvalues as well as eigenvectors, and we diagonalize them. So in order to find the diagonal matrix, where here the diagonal matrix D, it is equals to, we will put the first eigenvalue here 3, and the second eigenvalue is 7. So we will put in the diagonal diagonal positions. We are going to put these eigenvalues. And what is T matrix? T matrix is that what is the vector which is corresponding to this first eigenvalue. The first eigenvalue is 3, and the vector corresponding to it is 1 and minus 3. So you have to write 1 and minus 3 in the first column. And the second eigenvalue is 7, and we have to write the corresponding eigenvector to lambda 2 equals to 7 is 1 and 9. So we have to write 1 and 9 as the second column. So after writing this T, we are going to find its inverse of this matrix, the T inverse, that is always equals to that 1 over determinant of T into adjoint of T. Determinant of T is simple for 2 cross 2 matrix, that we multiply this with this. So 9 plus minus 3 into 1. So it becomes plus 3. So 9 plus 3, it will be 12. So this is how we are going to solve for the determinant. So it will be equals to 1 over 12. After that, what is adjoint of T? Adjoint of T is that we are going to change the position of these diagonal elements. So this becomes here and this comes here. And we change the sign of the other diagonal. So it becomes minus becomes plus, and here is plus. So it becomes minus. So this becomes as adjoint of T. That we just change the position of these diagonal elements and we change the sign of these diagonal elements. So we get the adjoint of T. After that, just multiply them. So 1 over 2 multiplied by 9, we get 3 over 4. And 1 over 12 multiplied by minus 1. So minus 1 over 12. So 3 multiplied by 1 over 12 will be 1 over 4. And similarly, 1 over 12 multiplied by 1 will be 1 over 12. So how to write down the next step, that x equals to t into y, where t, what is t? T is the matrix that we have just found. And in order to find y dash is equals to dy plus t inverse into g of t. So this you have to memorize, that what is this, how we are going to find the y dash. Y dash, it is always equals to d matrix multiplied by y plus inverse of t matrix multiplied by g of t. G of t is the non-homogeneous part, which we can see it from the question. Okay, so after that, v dash is nothing, y dash is nothing but y1 dash and y2 dash. D matrix is same, which we have just written as the eigenvalues 3007. So 3007. Y is y1 and y2 plus t inverse. T inverse we have just found this matrix. So we substitute over here. This is the inverse of t. G of t is minus 3 into e power t and minus 10 into e power t. This we get g of t part as from the question. That in the question it is given that what will be g of t part. So in the question, if we see, it is written over there. Yes, this is the non-homogeneous part. So this is minus 3 e power t and minus 10 into e power t. So this is how we just copy g of t from the question. After that, now we have to solve this for diagonalization. Here, substitute all these values and just multiply this with this. So these are the matrix multiplication, that row will be multiplied with column and this row will be multiplied by this column, and we add them. So 3 over 4 multiplied by minus 3 into e power t. So it becomes 3 into 3, 9 over 4 into e power t, plus this 1 over 12 multiplied by minus 10 over e power t. So it becomes 5 over 6 into e power t. So this will be multiplied by this. So it becomes 3 over 4 into e power t, and plus multiplied by minus will be minus into 10 over 12. So 10 over 12 will be 5 over 6 into e power t. Then we just simplify them, that 3y1 plus this part and 7y2 plus the second row. So we write down in the form of this equation. So after that, we will solve these equations separately. Like first, we will solve this first equation, y1 dash equals to 3y1 minus 9 over 4 e power t plus 5 over 6 into e power t. Firstly, we will solve for y1. So we write down the equation and we take this y1 term on the left hand side, and on this side we will keep with 34 over 24. How we get this? We just simplify them, take the LCM, add them or subtract them, whatever the given form is. So here we are just subtracting them and we get the answer as minus 34 over 24 into e power t. After that, just simplify, just cancel them. So the first equation we get y1 dash minus 3y1 equals to minus 17 over 12 into e power t. So we can solve this equation as the method of integrating factor, where we have to find the integrating factor as mu equals to e power integration of pt dt, where p is the coefficient of this y1, that is minus 3. So we have to integrate it and we get the answer that minus 3 into dt. So minus 3 is constant and dt's answer will be minus 3t. So e power minus c is the integrating factor, and we have to multiply this integrating factor with this equation too. When we multiply this, e power minus 3t, multiply these both sides by integrating factor. So we get, multiply this with this, so it becomes minus 17 over 12 into minus 3 plus t, it becomes minus 2t, and just this becomes the, how we are going to write it. It will be the derivative of d over dt, that in the integrating factor, we just write the integrating factor and multiply by this v1, y1. Integrating factor multiply by y1 and write down here d over dt. So when we multiply both sides by dt, so on this side also multiply dt. So this dt will cancel out, and we will left with just d of e power minus 3t y1 equals to minus 17 over 12 e power minus 2t dt. Integrate both sides with respect to t. So when we integrate this and this also, so this derivative and integration will cancel out. So on this side, we will get e power minus 3t y1 equals to, take the integration of this. So this is constant, take it out. So when we take the integration of e power minus 2t will be over minus 2, and just then multiply them and simplify them, plus the constant of integration, that is c1. After that, e power minus 2t, e power minus 3t, when we take it up, because we are just dividing both sides by e power minus 3t, because we want to find the value of y1. So just divide all these terms with e power minus 3t, so and simplify them. So we get y1 equals to 17 over 24. When we take it up, so minus 2 plus 3 will become plus t plus c1, and this also when we take it in the numerator, so it becomes e power 3t. So this is how we are going to find the value of y1. Similarly, we are going to find the value of y2, that the second equation was of this form, y2 dash equals to 7y2 minus 3 over 4 et minus 5 over 6 et. And when we are going to take it on this side, so y2 dash minus 7y2, and this also when we simplify them, we get minus 38 over 24. And when we just reduce to or simplify them, we will get minus 19 over 12 e power t. Now we have to use the method of integrating factor, where p is here, this one, this coefficient is called p, and take its integration, that is minus 7's integration. So it is constant, so it will be taken out. So 1 dt's integration will be t. So the integrating factor we get here will be mu equals to e power minus 7t. So we will multiply this integrating factor with the given equation, both sides. We will multiply with the integrating factor. So when we multiply the right hand side, we will get minus 7 plus 1t. So it will be minus 6t. So 19 over 12 into e power minus 6t. And this we can write down in the simplified form, that it is the derivative of d by dt of integrating factor multiplied by y2. So integrating factor multiplied by y2, we can write it is the derivative of this. Okay. So after that, multiply both sides by dt, and when we integrate them, so derivative and integration goes, so we get e power minus 70 y2 equals to minus 19 over 12. Take the integration of minus 60, e power minus 60's integration is divide this with minus 6 and simplify them. So minus 6, and we multiply with this becomes 72, minus minus become plus, and e power minus 60 is here plus c2. So after that, just divide all the terms by e power minus 70. So when we divide e power minus 70, this and this also, so in the end we get the value y2 equals to 19 over 72 e power t plus c2 e power 70. Since now we are going to, we have supposed in the first step that the solution of the given non-homogeneous linear system is of the form x equals to dy, where t is the matrix. What we have, this matrix is actually eigenvectors. So this is the eigenvector which is corresponding to the first eigenvalue, and this is the eigenvector which is corresponding to the second eigenvalue. So T matrix is depending on the eigenvector. Y is just y1 and y2. After that, y1 and y2 is what we have just find this is y2, and in the last step also we have found y1. So just substitute these values in this matrix, that it is y1 and this is y2, and then just multiply them. This is the matrix multiplication, that 1 multiplied by this all plus 1 multiplied by this all. So 1 multiplied by this, so we get the same answer, 17 over 24 e power t plus c1 into e power 3t plus 1 multiplied by this also. So 19 over 72 into e power t plus c2 into e power 70. And when we simplify them, we will get the required answer, that this and this we cannot simplify. So we will keep as it is, c1 into e power 3t and c2 into e power 70, but this and this we can add them. So this, when we add them, we will get the answer 60 over 72 e power t. Similarly, the second row will be multiplied with the first these first elements. So minus 3 multiplied by this plus 9 multiplied by this. So when we multiply minus 3 with this, we get minus 17 over 8 e power t. And when we multiply this with this, so we get minus 3 into c1 e power 3t. Similarly, when we multiply 9 with this and 9 with this term, so we get these 19 over 8 e power t plus 9 into c2 e power 7t. And when we simplify them, these two terms will be same, that minus 3 c1 e power 3t and 9 into c2 e power 70, this will be same, but these two terms we can add them. So when we add them and simplify them, so the final answer will be 2 over 8 into e power t. After that, we can write this all matrix in this form also, that the first terms, they are c1. So we are taken c1 common, and e power 3t is also same. So you can write here e power 3t, and the other are the coefficients. So the coefficient of this is 1, and the coefficient of the second term is minus 3 plus c2. The second term, now we will write c2 is common, e power 70 is common also, and the coefficients are 1 and 9. Plus, we are going to write the third term, that e power t is common, and the coefficient is 60 over 72. And the coefficient of this is 2 over 8. So when we just simplify them, just cancel them out, the final answer or the final solution for the given non-homogeneous linear system of equation will be c1 into 1 minus 3 e power 3t plus c2 into 1 9 e power 70 plus 5 over 6 and 1 over 4 into e power t. So this is the required solution for the given non-homogeneous linear system of equation.